So maybe I'll cover it up so it won't make you dizzy while I'm moving over there. Okay, we have 2 tubes, either of those 1-inch glass tubes, and the top one would be what it looked like when I first set it up. And I set this up a couple of hours ago. Oh, you're beginning to see something in the second one that you don't see in the one that was just set up. At first, it was just a tiny little band or ring, and as time has progressed, that's got wider and wider. And since it's rings, just kind of draw that series of rings like I showed on the board. And this is a white solid. That is that acid salt. So the what took place is what you're observing here, and you need to explain why. And so if it looked like that for the first probably 30 minutes, then what happened when both of those were moving from an area of greater concentration to an area of lesser? Oh, the stapler just keeps them rolling off the table there. So this is the acid salt. So you have the visible acid salt, and then you show the drawing water, and that's going to form right here, but it hasn't formed droplets large enough to see. So that's the what took place. You're observing it. You have it on your drawing. It may be difficult for me to get this part done, and I'm going to show you this is the procedure with the potatoes, and you'll see that there's 3 French fries here, and I tried to make them close to the same size as I could, but you see they're all the same length, and I'm going to pick one up and shake it and observe about the degree of flexibility. I'm going to press it on the table, and you can see about how flexible it is. And shake it and push it on the table, and you can see about how flexible it is. And then I kerplunked them and put them in the 3 different solutions. So moving right along, here's the one I placed in the 0% salt water. So I'm going to pick it out and lay it down. And now I'm going to bang it on the table, and I'm going to shake it, and you don't see any flexibility there. I'm going to press it again, and you can see it's quite stiff. So I'm going to leave it laying right there, and I'm going to pick the one out of the 1% salt, and you can see it looks about like before I put it in. See, it's got some degree of flexibility, but it's not near as rigid as the first one. Let me line them up here. Oh, hey, there's a difference there. They started off the same length. Now I'm going to get the one out of the 10% salt and bring it over here, and I'm going to shake it. Whoa, so on what took place, you're describing the change in appearance, and I'm going to place it over here by the others and line it up. This one was in the 0% salt water, and I think you probably had your arrows indicating from greater to lesser it was going to go into it. The one on the 1% or 0.85%, it stayed about the same. This is what they both look like beforehand, but see the flexibility? This is kind of what it looked like before I put it in there. And this is the 10%. It's limp as a wet dish rag. So did it cooperate and the molecules go from greater to lesser according by definition? Okay. Now this is procedure of the potassium permanganate. Oh, I'm going to have to back up. And you have a before drawn, and I'm going to zoom down here, and you can see that the color is concentrated in the very bottom. I dropped that in there probably 30, 40 minutes ago. So it's highly concentrated in the bottom. There's a little in the upper part, but the crystal dissolved a little bit on the way through the water. And this is the one I set up yesterday. Wasn't stirred. So this is the before. This is after. Now all was in there was air, and I put water in there and the potassium permanganate. So the subheading is going to be either diffusion or osmosis. So why did it go from looking like this to looking like this? So the what is, you describe the difference in that, and the why is, for instance, where was the potassium permanganate more concentrated or greater? And where was the concentration of water greater? Were they both going from greater to lesser until they look like this? And oh, I dread this, I already smell it. And this is that last drawing. There's a liquid in there. And my eyes are burning. And man, it opens your head up. If we're doing this in lab, I'd have it on the demonstration table, and man, I'd be just dying, and I'd tell them to, when they smell it, raise their hands. And obviously the closest one would raise their hand, and then as it was doing something, people would start raising their hand, and I would get it dumped, because it's not very pleasant. Okay, I'm going to cover it up here and get over and show you how this was set up. And like I said, we're going to have to fake it, because it hasn't had time to work. If I don't get tangled up in my line here. Okay, you can see the cow bladder is tied on there with a rubber band. And you can see that I have some air pocket at the very top of that, and there's a little of the up there. So that's the before, except I got some of the honey up there in the tube. So you have it drawn kind of without that in the tube. And so that's the semi-permeable membrane, 100% water outside, 10% sugar, 90% water inside. That's the before. So that's the level before osmosis on the water and the material in the tube. And given time, we come on up here. And well, I think I'm drawing. Oh, here we are. It's focusing on, oh, okay, right there. At one time when I did it, that black mark indicates how high it had risen. And like I say, given time, it goes up and actually runs over the top. So you're going to have to fake it. So right about here, like you see on my drawing page, put a dotted line to indicate that that's something that happened later. And it went up. And if the level in the tube went up, the level in the water had to go down. So that completes exercise 2A. Now, I'm going to zoom in on all three one more time. Of course, at any time you needed to stop and spend more time with it, you can do that. So here's the procedure 1 again. There's the procedure 3 with all the labels. Well, I guess you could have paused it and already seen it, but I'm going to do it again. Off to the right is where you describe what happened. Now, you didn't see it, but you're going to have to fake it, but then explain why it did what it did. On this one, you see what took place from description and then explain why. And, oh man, it's just stinking the room up now. That's the ammonium hydroxide, what and why. So I'm about to cut off here, and I'll be getting this to you as soon as I can figure out how to do it again. Have a good weekend.